This is the Unit 3 review key. So, starting with graphing rational functions, first thing we have to do is we have to factor the top and the bottom of our fractions. We can take a 4 out of the first, or out of the top, we're left with x minus 2. On the bottom, we can factor this to give ourselves x plus 3 and x minus 2. The x minus 2's will go away. We'll be left with 4 over x plus 3. Okay, now that's what we're going to use to solve all the other pieces for our problem. All right, for our y-intercept, we put 0 in for all the x's. So we'll be left with, so we have 4 over 0 plus 3. We have 0 comma 4/3 for our y-intercept. And I'll graph that. So 4/3 is like 1 1/3, so it's a little bit over 1. Put a point a little bit above 1 on the y-axis. For the x-intercept, we take the top, our numerator of our fraction, set it equal to 0, which doesn't make any sense because 4 does not equal 0, which means there is no x-intercept. So we put none. For our vertical asymptote, put x plus 3, which is the denominator, set it equal to 0. Solve for x. We have x equals negative 3. So that's our vertical asymptote. We're going to make our dashed line at negative 3 vertically. For our horizontal asymptote, we have the leading terms of our fraction. So we have 4 over x. Remember, you're putting a really big number in for x, and 4 divided by a really big number is something close to 0. So it's going to be y equals 0 is our horizontal. This makes sense when we think of the fact that we don't have an x-intercept. It's because we have a horizontal asymptote at 0 on the x-axis. So our dashed line goes there. Holes. We do have a hole because we canceled something out. We took x minus 2, set it equal to 0, so x will equal 2. We're going to use that in our problem. So we have 4 over 2 plus 3, which gives me 4 over 5. So our hole is going to be 2 and 4 over 5. So 2 and 4/5 is going to be about there. There's our hole. And then our sign analysis. In this case, we do need a sign analysis because we don't have any information to the left of the vertical asymptote. So I'm going to use negative 5 as our value. Put negative 5 in for the x term. If we do that, we're going to get 4 over negative 5 plus 3, which gives us negative 2. So our point would be negative 5 comma negative 2, which is right there. And now we have points on either side of the vertical asymptote. Just draw our graph. Making sure that we are careful that we don't put the line through the hole. We put it, it's got a jump hole. There's our graph. All right. Number 2. Factor the top and the bottom of our fractions. On the top, we're going to get x plus 4 and x minus 1. On the bottom, we're going to get x plus 4 and x plus 2. So what we're going to do is cancel out the x plus 4s. So we have x minus 1 over x plus 2, which you've been using that to find out, use that to find out information on the right-hand side. Y-intercept, put 0 in for all the x's. We'll get 0 minus 1 over 0 plus 2. So our y-intercept is going to be negative 1/2. Put that point down, just right about there. X-intercept, take the top, set it equal to 0, which gives us 1. There's our x-intercept. For the vertical asymptote, we're going to take the bottom of our fraction, set it equal to 0. X will equal negative 2. For a horizontal asymptote, we have x over x, which will give us 1. Y equals 1. For the wholes, what did we cancel out? We canceled out x plus 4. So x plus 4 is equal to 0. X will equal negative 4. This is the first value we're going to have. We put that into our equation. We have negative 4 minus 1 over negative 4 plus 2. We'll get negative 5 over negative 2, which is positive 5 over 2. So there's our whole. So negative 4 and positive 5 over 2, which is 2.5. Let's get this right there. There we go. All right, now we don't need a sign analysis because we have values or points on both sides of the vertical asymptote. We can just graph our equation. Again, making sure that we don't go through the hole, but bounce over. There's your graph for number 2. Number 3. Again, we're going to factor. You can take a 3 out of the top. As the greatest common factor. On the bottom, we have x plus 3 and x plus 2. The plus 3's can cancel, so we'll get 3 over x plus 2 as our equation. Y-intercept, put 0 in for the x, so we have 3 over 0 plus 2. 3 over 2 is our y-intercept. So that's 1.5. Go right there. Your x-intercept, you have the numerator, 3 equals 0. This is not true, so there is none. Vertical asymptote, just like kind of the first one, we have 3 over x. Putting a very large number in for x, we get y equals 0. Oh, sorry, hold on. I skipped ahead. My apologies. Vertical asymptote is x plus 2 equals 0. Solve for x, we'll get negative 2. Now the horizontal asymptote is the leading term, so we have 3 over x. Much like the first one, we put a very large number in for x. We get 0 is equal to y. Again, this is why we don't have a x-intercept, because there's a horizontal asymptote on the x-axis. Holes, we did cancel something out. We canceled x plus 3, so we have x plus 3 equals 0. X will equal negative 3. We're putting that back into the equation. 3 over negative 3 plus 2, which gives us 3 over negative 1, which is negative 3. So negative 3 and negative 3. That's our hole, so it's going to be right here. And since we have a point or a hole on either side of the vertical asymptote, we don't need a sign analysis. We just graph our line, again, making sure that we don't go through the hole. This is an important piece of information. If you do the test, you will get marked off. And that's number 3. All right. Composite functions. All we're doing is we're putting in these values into the functions that we're given. So the first one, f of negative 7, we're going to put negative 7 in for the f function. So we're going to put 2. And we're going to replace the x in the f function with negative 7. We're going to make sure we always put those in parentheses, plus 1. Well, 2 times negative 7 is negative 14, plus 1 is negative 13. That's our answer. Next, we're putting x plus 1 in for the x of the g function. So it's going to look like this. 3x plus 1 squared. Now in order to do this, we have to square the x plus 1 first, which is the same thing as getting rid of the squared and multiplying it times itself. We have to do that part first. That would be the best idea. We do x times x, which is x squared. X times 1, which is x. 1 times x, which is also x. 1 times 1, which is 1. Now, I'm still multiplying this by 3, but I'm going to wait to do that until I combine the like terms so I don't have to multiply by so many things. So I have x squared plus 2x plus 1, all being multiplied by 3. And now I have 3x squared plus 6x plus 3. G plus h of 6. So I'm putting 6 into both the g and the h function, and then I'm adding them together. So I have 3 times 6 squared. Notice I put the 6 in parentheses for the g function, plus, I'm going to put this part in her parentheses as well. I have 6 squared plus 2 times 6. Okay. Putting the second part of the function in parentheses is a good idea, especially when you're going to subtract things. It causes you less problems in the future. So I have an issue. I'm going to bring up the calculator just because it's easier for me to do this way. Okay, so 6 squared is 36 times 3 is 108. Sorry, this always happens. Don't know why. Get back in this. So we got 108 plus 6 squared is 36 plus 2 times 6 is 12, which gives me 48. 48 plus 108 is 156. There's your answer for the next one. All right. Here we're doing g minus h with the x function. So we have g is 3x squared minus, what is it over here? The h function was again x squared plus 2x. It's really important that you put the h function in parentheses because you have to distribute this negative sign to both terms in here. So 3x squared minus x squared is 2x squared, and then negative 2x. And then you're done. Okay, we just put x in for the x values, which doesn't change them what they are. Here, now we're putting this as a composite, putting this negative 1 into the h function first. So let's do that. So h is x squared plus 2x. So I'm going to have negative 1 squared plus 2 times negative 1. I'm going to figure out what that is first. Once I find out this answer, I'm going to put that answer into the f function. So I'm going to get 1, because negative 1 squared is positive 1, minus 2, which gives me negative 1. I'm going to put this into the f function now. The f function is 2x plus 1. So I have 2 times negative 1 plus 1 gives me negative 2 plus 1, which is going to be negative 1 still. So that is my final answer. This is my correct answer. Okay. All right. This is very much the same thing as almost like the other one that we just did. It's a composite just written differently. We're putting 0 in for the f function. So again, the f function is 2x plus 1. I'm going to put 2 times 0 plus 1. I'm going to figure this out. 2 times 0 is 0 plus 1 is 1. So I'm going to put that number into the f function again. So 2 times 1 plus 1 is going to give me 3. All right, going over here. All right, same idea. I'm going to put negative 3 into the h function and then put the answer to that back into the h function again. H function, as a reminder, is x squared plus 2x. So I have negative 3 squared plus 2 times negative 3. It's going to give me 9 minus 6, which would give me 3. I'm going to put that back into the h function again. So I'm going to have 3 squared plus 2 times 3. Again, this gives me 9 plus 6, so I'll have 15. Here we're going to take their two functions. We have h of 10, so I'm going to put 10 in for the h function, which is going to give me 10 squared plus 2 times 10, and minus, let's just refer back to the f is 2x plus 1, 2, negative 1 plus 1. Make that bigger. Okay. So at first we have 10 squared is 100 plus 2 times 10 is 20. So we have 120. minus 2 times negative 1 is negative 2 plus 1 is negative 1. And then because the two negatives are there, you're going to actually add, because the negative times the negative is a positive, so you have 121. Last one of these, putting you're putting x into the g function, which doesn't change it at all. So we still have 3x squared. I'm going to put that value into the h function. So we're going to have 3x squared being squared plus 2 times 3x squared. So we're just putting the g function into the h function as it currently exists and then just figuring out what we have. We're squaring using this 2, all the terms in here. So 3 squared is 9. When you raise a power to a power, you multiply the powers. So 2 times 2 is 4. Plus, you're multiplying 2 times 3, which gives you 6. The x squared doesn't change, so you have 6x squared. So this is your answer for the last one. All right, let's look at some logs. We can get rid of this for a little bit. Write the equation, the following logarithmic equation as an exponential equation and solve. So if we smash the log, the 4 becomes the base for the exponent of 2, which equals x, and 4 squared is 16. 21, write this as a logarithmic equation. So the 5 is the base, which becomes the base of the log. The x was the exponent from the other side, and you got 125 right there. Okay, we're going to condense this. So one of these terms has a coefficient. That would be the 3. That's going to become the exponent on the x. All right. And because we are adding, we're going to be multiplying. So we have log base 4 of 5 times x to the third. Well, that's it. Expand this. All right. So because these 6 and the y are being multiplied, you're going to add. So we have log based x of 6 plus 2 log based 6 x of y. Notice the 2 goes in front of the log to become a coefficient because it was an exponent. All right. Next, condense. We're subtracting, which means we're dividing. So we have natural log of 5 over 3. That's it. Okay. Now there's a bunch of things happening here. We're multiplying 4 and x together, but we're dividing by w. So the 4 and x are going to be plus, w is going to be minus. So we have natural log of 4 plus the natural log of x minus the natural log of w. And that's it. Here we're going to be doing a combination of condensing and solving. So the two previous things we've done. So here we have log of, since we're adding, we're multiplying. 5 times 20 is 100 equals x. Okay, now we have to smash the log to solve the equation. Now the base of this, because it's not written, is going to be 10. So that 10 is going to move over to become the base of the exponent of x, which equals 100. And the x, 10, what power gives you 100 if you raise it from 10 is 2. So 10 squared is 100. Okay. Here we have some exponential equations. We have to change their bases because the bases aren't the same. Now 16 can be rewritten because it's the bigger number as 4 squared. We're going to multiply 2 times x and 2 times 1. So we have 4 to 2x plus 2 equals 4 to the x minus 1. Now that the bases are the same, we can cancel those out. So we have 2x plus 2 equals x minus 1. We subtract x on both sides and subtract 2 from both sides. So we have x equals -3. And we're done. Here, same idea, but the bases are already the same, so we can just get rid of those. So we just rewrite the exponents as the equation. I'm going to see how do I do this. I'm going to subtract 3x to make my life a little bit easier. Add 6 and get 10 is equal to x. And that's it. Here again, we have to change the bases. 27 can become a 3 cubed. Raised to the 4th power, and 3 to the 2x. Now we're going to multiply the exponents on the right. So we have 3 to the 2x equals 3 to the 12th. We're going to cancel out those bases. So we have 2x equals 12. Divide both sides by 2, and x equals 6. Moving on. 4 more to go. We're going to need the calculator back for these. So I'm going to put this back in here. There we go. Awesome. Okay, so now these are non-like bases. We have to change these to log. So we're going to have x, I get it, log of 3 equals log of 8. To solve for x, I'm going to divide both sides by log of 3. So I have x is equal to, now this you're just going to do in the calculator. So you have the log of 8. Make sure you put that in parentheses, divided by the log of 3. Close the parentheses on that again. Equals 1.89. Next, again, we have non-like bases. So we have x log of 4 equals 2 log of 7. Now we want to solve this for x. We're going to divide both sides by log of 4. So if I put in the calculator, I have 2 times the log of 7 divided by the log of 4. Equals 2.81. Moving on. Now we're getting a little more complicated. I'm going to have 3x log of 5 equals x minus 6. I'm going to put that in parentheses, log of 4. This one's a little more complicated because we have x's on both sides of our equal sign. Okay, so what we're going to do, we're going to distribute the log of 4 to the x and -6. So I have 3x log of 5 still on the left equals x log of 4 minus 6 log of 4. Okay. Now to get the x's on the same side, I'm going to subtract x log of 4 to the left to give myself 3x log of 5 minus x log of 4 equals -6 log of 4. Now that all my x's are on the left, I can take one out. I can take a greatest common factor of x out, and I'll be left with 3 log of 5 minus log of 4 in parentheses equals -6 log of 4. And now I can divide both sides by what's in the parentheses. So I'm going to put that in my calculator, -6 log of 4 divided by, I got to put this whole thing in parentheses, 3 log of 5 minus log of 4. And that's going to be the way it looks. Hit equals. I get x is equal to negative 2.42. That was a little more complicated. There it is. Lastly, we have this one. So same kind of idea. We have x plus 1 log of 8 equals log of 20. Now in this one, unlike the last one, we don't have multiple x's, we just have one. So we can do a little bit of a shortcut. We can divide both sides by log of 8. To cancel out that, we have x plus 1 equals log of 20 over log of 8. We can subtract 1 from both sides. So I'm going to put this into the calculator. It's going to be log of 20 divided by log of 8. And then I'm going to hit equals just because I want to. And I'm going to add 1. No, I'm going to subtract 1. There we go. And there we go. So I'm going to do x equals 0.44. And that's it. That is the review for Unit 3. Good luck on the test.